Coffee, good. So if the Q multiplier improves the selectivity, I guess we got to go to selectivity next, right? Selectivity. So I skipped a whole lot of stuff. I just zoomed all the way down, but you know, there's a lot going on here. But I just thought we'd kind of stick with a theme here just for a minute. And of course, we could go through this, or someone can go through this again, but selectivity, they do talk about selectivity, and it's explained the theory of it in detail. But one thing that I noticed is that they're talking about, where is it? They refer to this figure here and figure C. And I should have went through LC coupling, but I didn't. You know, I'm just covering some highlights here. I don't know, this is probably not the best way to be talking. So inductive coupling. But anyway, so just a little bit here, they talk about down here, they go, in that last one, that was 243C, here it is, bada boom, inductive coupling, and they say, if we can ever get to the topic I'm trying to explain here, right here, they talk about Q again. In that last little video, they talked about when the guy was explaining what a Q multiplier does, improves selectivity. I think I'm onto something here. So the Q's of individual circuits are affected by the degree of coupling because each couples resistance into the other. The tighter the coupling, the lower the individual Q's, and therefore the lower the overall selectivity. So they do kind of explain, they call these humps, and they explain how these, you know, appear depending on all this information on how the tuning of a coupled circuit affects all that. This is like a variable capacitor, I guess. Like there's things in here that I don't know if they're even taught anymore. Like here's one here where they're talking about these different humps in here, and they're saying here, where is it? I just saw it. When two circuits are tuned to slightly different frequencies, a double humped resonance curves results even though the coupling is below critical. This is to be expected because each circuit will respond best to the frequency to which it's tuned. Tuning of this type is called stagger tuning, and often used when substantially uniform response over a wide band of frequencies is desired. I think we're kind of getting like a real description of what selectivity is. So just try to tie in Q and selectivity together and see if I can find some kind of understanding on it. It's a lot to understand. It's a lot of stuff to comprehend and work through. I think it's time to stop for a while and let the brain cool down. Have a good day, folks. Once again, 73 from your old pal, CLG. Oh, yeah.